Hi everyone, my name is Alison Jing from the Empathic Computing Lab of the University of South Australia. I'll be presenting our paper titled Comparing Gaze-Supported Modality with Empathic Mixed Reality Interfaces in a Remote Collaboration. In this paper, we explore the impact of near gaze and embodied interfaces for sharing different real-time communication modalities and biofeedback in collaborative mixed reality experiences. This paper has novel aspects, making the following contributions. Proposes a novel concept of a near gaze interface, which visualizes multimodal cues near the user's gaze position to enhance MR remote collaboration on a physical task. Second, present a proof of concept implementation of a 360 MR remote collaboration system, which integrates real-time collaborative gaze behaviors, hand gesturing, and shared biofeedback heart rate. Reports on a user study which evaluates combining shared gaze visualizations and hand interactions in near gaze interface compared against commonly used embodied interface. In face-to-face collaboration, people can freely access both implicit and explicit communication cues, including eye contact, speech, hand gesture, facial expression, etc. However, this becomes more challenging when collaborating remotely on a physical task. Studies conducted using mixed reality systems with 360 panoramic video sharing have created opportunities to create a shared physical task environment, allowing collaborators to share dynamic view from different angles and positions. Gaze-supported modalities have been explored in conventional 2D displays between remote collaborators, but are yet to be fully studied in MR environments. The distribution of attention in a spatially complex environment, adding view angles from different locations can negatively influence collaborators' mutual understanding towards the task during multimodal MR interactions. Lastly, understanding collaborators' feeling and emotion can also lead to successful remote collaboration, hence reducing cognitive load while creating more empathy. However, it is unknown if showing real-time biofeedback to both collaborators will stimulate different empathic communication between pairs who have access to multiple modalities while having varying levels of attention division during task collaboration. Therefore, our overarching research question intends to understand how communication modalities will be utilized during task coordination when different representations of virtual cues, either near the partner's gaze focus or at an embodied location, affect the division of attention and the perception. To address this, we present a collaborative MR system that visualizes hand pointing, gesturing, and heart rate either independently from embodied or associated with near gaze, the user's gaze focus point. This prototype allows us to explore three main aspects of the research question. 1, how each modality affects collaboration. 2, how attention is distributed between dependent and independent gaze views. And 3, how real-time biofeedback affects empathic communication in different gaze views. Our prototype system offers gaze-supported multimodal interactions, combining hand pointing, gesturing, and heart rate visualization through a live 360 panoramic video-based mixed reality collaboration environment. Users are able to freely exchange bidirectional real-time shared gaze cues and other communication modalities between a local worker and a remote expert via symmetrical input and output methods, while being able to constantly monitor each other's heart rate changes via an animated bar updated every second. There are two different types of interfaces. Near gaze interface visualizes the user's gaze, hand, and physiological cues close to the collaborator's gaze point, resulting in fast identification of the shared target inside of the current task view. Embodied interface, on the other hand, visualizes the same cues based on their estimated body positions, providing a natural and continuous interaction mimicking real-life human movements. The setup of the pilot study was designed to be an expert evaluation format among proficient MR users. Our approach addresses the concern of lacking familiarity with novel gaze interfaces among current users. We recruited proficient MR users who potentially exert shorter learning curves to minimize bias between gaze and hand gestures. This study explores two interfaces design, NG and EM, through a remote asymmetrical task collaboration, novice versus expert, aiming to further understand the effect of gaze behaviors, hand pointing, gesturing, and heart rate biofeedback in an MR empathic remote collaboration setup. There are 4 groups of 8 experienced MR participants. A within-subject design with two conditions of the interfaces are employed. A collaborative puzzle-solving task was used, perceived message understanding, single ease question, subjective mental effort question were measured. An in-back baseline was set to evaluate the cognitive load before the experimental task. Semi-structured interview and observations were added for the quantitative analysis. The use of a modality in the pilot results showed a trend of shared gaze being primarily used compared to hand pointing and gesturing. Real-time bidirectional biofeedback suggests a need for future investigation within tasks that requires collaborators to actively exchange essential contextual and emotional information, then purely focusing on completing the task itself. The use of a modality in the pilot results showed a trend of shared gaze being primarily used compared to hand pointing and gesturing. To further investigate, we conducted a formal study considering modalities and interfaces as two factors to compare against, aiming to find effects and interactions to answer the remaining unknown questions. 12 groups, 24 people are recruited, among which 50% have never to slide experience using gesturing interfaces, and 42% have never to slide experience using gaze interface. 67% were identified as strangers for the collaborative task. We used a within-subject factorial design with the two independent variables, modality and interface. Modality includes gaze plus hand and hand only. This design compares the conventional gesture-focused modality to the modality with added gaze behaviors, aiming at understanding how natural gaze behaviors affect the primary use of communication modalities. Interface consists of near gaze and embodied, which extends the pilot study to further understand the division of attention between task focuses and collaborators' embodiment. A collaborative task of two steps are used: locate a target collaboratively and solve the puzzle after. We use both objective and subjective measures to evaluate. They are completion time, joint attention behavior, which includes joint gaze percentage, point to signal, point to clarify, and joint attention standardized counts. For subjective, we have a co-presence questionnaire, user rating, user ranking, NASA TLX, and system usability scale. In conditions where shared gaze cues are enabled, participants intended to rely primarily on gaze to achieve joint attention and target alignment. Hand interaction becomes less utilized to signal or clarify task intention. In conditions where only hand is available, there's a positive effect of hand pointing on joint attention. However, no such effect is found when gaze is added to hand. This possibly indicates that even when gaze and hands are both available, participants still use gaze as a main method to reach mutual understanding. Subjective measures indicate that compared to the baseline, participants find gaze plus hand or near gaze elements help reduce task load while improving co-presence, understanding towards each other, and tight behavior interdependence. Near gaze assists participants remain focused without the need to divide the attention, provide an estimate position of the partner's current location, even when the gaze is not explicitly shown, whereas embodied interface feels more natural and less distracting. Depending on task requirements and viewing dependency, adding user agency to choose the display of visual information and representation needs further investigation. For the design guideline for referential pointer, consider incorporating shared gaze visualization coupled with the Dixis as a primary method and hand pointing as a secondary confirmation in a subtle visual format. For hand gesturing, consider using a near gaze interface when the task object and collaborators' body positions are further apart to avoid attention division. On the other hand, apply an embodied interface when natural interaction is essential for tasks requiring an expert full body attention. For example, local worker looking towards a remote expert. For biofeedback, including them when the task requires the expert to adjust communication style based on novice users' cognitive ability or between communicators who are not good at using other available communication modalities, such as describing themselves verbally, as well as those who are still in process of developing familiarity. So to conclude, in this paper, we present a live 360 panoramic video-based mixed reality collaboration system, sharing gaze, hand pointing, gesturing, and heart rate visualization between remote collaborators with two types of interface designs, near gaze and embodied. Results suggest that participants primarily rely on a shared gaze behavior coupled with dictate language to affirm joint attention and mutual understanding, followed by hand pointing and gesturing as a secondary method in free-form task space. Depending on the task property and setup, the near gaze interface allows users to focus on a target object without constantly attending to the collaborator. Participants also perceive adding gaze in representation help reduce task load and improve co-presence. Without the need to search for participants' current location and body movements, users can remain focused on the shared view space in the gaze plus hand in near gaze condition, resulting in tightening collaboration behaviors. While the embodied interface provides natural full-body interaction, although not actively used by our participants, real-time bidirectional biofeedback suggests a need for future investigation within tasks that require collaborators to actively exchange essential contextual and emotional information than purely focusing on completing the task itself. Thank you very much for your time. You can reach me or my lab the following method. Thanks.